Lecture we will see how we are going to convert a Nyquist contour path for any given g of s h of s into the Nyquist plot in g of s h of s plane. Okay, this is a general case. Okay, and the Nyquist contour path, you are you need to you should not consider the poles on imaginary axis. So suppose if I consider g of s h of s like k by s into 1 plus st1 into 1 plus st2, here the imaginary axis poles are only s equals to 0. So leaving that, you need to consider all the possible paths in Nyquist contour path. That means I have shown four parts. First one is when omega is varying from 0 to infinity, and the second one is when theta is varying from 90 degrees to minus 90 degree. Similarly, the third one is negative imaginary axis, that is omega is varying from minus infinity to 0. Similarly, fourth one, excluding the poles on imaginary axis, that is epsilon semicircle, that the epsilon is radius and the range of theta is from minus 90 degree to plus 90 degree. Okay, so all these parts 1 2 3 4 are in Nyquist. 1 2 3 4 parts are in Nyquist contour path. So our aim is to convert that Nyquist contour path to Nyquist plot in g of s h of s plane. Okay, how you are going to do that? So for each part you are going to look at it. So for first part, that is positive imaginary axis, s equals to j omega and omega is between 0 to infinity, right? So for this you need to plot polar plot. That means the uh, Nyquist plot is polar plot for that particular part plot, like you observe the words. So for positive imaginary axis part, the Nyquist plot is polar plot, right, where omega is varying from 0 to infinity. Then for second part, which is of radius r semicircle, and the theta is varying from 90 degree to minus 90 degree. So here the radius r is infinity, right? So what's happening to the value of s in that case? So s equals to limit r tends to infinity, capital R e power j theta, that is sigma plus j omega represented in polar form. That's it. Okay, so when r tends to infinity, what's going to happen? The total Nyquist plot is going to merge to origin. Okay, right. Yes. So yes, right, because k divided by s into 1 plus st into 1 plus st2. If you do this, r tends to infinity, r e power j theta, which is s, you will get what? 0. Right, that's what I'm showing. Then coming to the negative imaginary axis, it is very easy because it is just a mirror image of the part 1. So in the Nyquist plot, which is the polar plot, for this third part also you will get just a symmetric with respect to the real axis of first part. That means in the first part you will draw one polar plot, right? Then the same plot which is symmetrical with respect to real axis you will get for third part, right? Okay, I have shown that there. Then come to the fourth part, which is of radius epsilon semicircle, and that epsilon is 0. Okay, so here st equal to limit epsilon tends to 0, epsilon e power j theta, right? In that case, what you are going to get in case of Nyquist plot, it will be a radius of infinity. Okay, so it is a semicircle clockwise with infinity radius. So these are the four important parts which you need to convert into Nyquist plot in g of s h of s plane for any given g of s h of s, right? Okay. After plotting, you will get to know that the number of clockwise infinity radius semicircles in Nyquist plot will be equals to type of the system, which is nothing but the number of poles of g of s h of s at the origin. Okay, the type of a system is nothing but the number of poles at origin, and it is for g of s h of s, because we are drawing Nyquist plot for g of s h of s, right? Okay, and one more important point, like Nyquist plot encircles the origin as many number of times as the right side poles minus zeros of g of s h of s. Okay, like this is encircling the origin, not minus 1 comma 0. So previously, like we have seen the encirclements of minus 1 comma 0 for stability criteria, but you can also get the encircles of the point 0 comma 0 by this formula, that is open loop poles minus open loop zeros. Okay, and that too right side, which are of right side, but for minus 1 comma 0 it is right side poles minus zeros of characteristic equation. That is important, that is the difference. Okay, thank you.